Good morning, students. Students, till now we have discussed the properties and formation of image in case of a plane mirror. Now we will further learn about spherical mirrors. Students, the topic spherical mirrors, image formation and their uses is covered in chapter 7, reflection of light, for class 8th, and this particular topic is given on page number 157 of your physics textbook, Concise Physics by Selena Publications, and is being submitted to you on 30th November 2020. So all of you may now open page number 157 in front of you. Students, till now we have studied about the image formation in case of a plane mirror. In case of a plane mirror, the image formed was always of same size as that of object and was always erect. That means wherever your head is in the image also, at the same point you are having your head. And the size, the height of the image is same as that of the height of the object. But students, in certain cases, you might have experienced that there are many kinds of mirrors in which the image can be inverted, that is upside down. The image can be magnified, the height of the image is more than the object, and sometimes the height of the image is less than that of object. Especially if you go in any fete or fair, you have certain games regarding mirrors in which if you are standing in front of a mirror, your image will be either upside down, that means the image formed, your head will be down while your feet might be observed upward. There can be your height and weight of the image is more as compared to you, or the image of your inside the mirror is smaller as compared to the object placed outside. So students, such mirrors are known as spherical mirrors. So spherical mirrors can be defined as a reflecting surface which is a part of a sphere is called a spherical mirror. So what is a spherical mirror? A reflecting surface which is a part of a sphere is called a spherical mirror. Spherical mirrors are of further two kinds, concave mirror and convex mirror. So students, before starting the concave and convex mirror, I want you all to do one activity. You have to take a spoon. Students, a spoon acts as a concave and convex surfaces. If you see a spoon, the inner surface of the spoon where you put vegetables to eat act as a concave surface, while the outside surface of the spoon acts as a convex surface. The inside surface of the spoon is acting as concave, while the outer surface of the spoon is acting as convex. Now students, you take a spoon, take the outer side of the spoon, and in front of this outer side of the spoon, keep a pen in front of it. Observe the figure, the image coming inside the spoon. The figure will be small, the image can be seen smaller, and it is erect. That means wherever you are having cap of the pen, at the same place in image also you are having the cap of a pen. Now students, reverse the position of the spoon such that now the object, the pen, is placed in front of the concave part of the spoon. Concave part means the inner part of the spoon. Students, see the image. If you change the position of the pen, if you bring it closer to the spoon or you take it farther away from the spoon, students, the image will change its shape and size. At one place, the image can be seen inverted also. Inverted means the cap is shown downward in the image. So we will study this concave and convex mirror next week. But just see the kinds of image formed when you are placing a pen in front of both the surfaces of the spoon. Now let us study first of all the concave mirror. Students, a concave mirror is made by silvering the outer or bulging surface. So we are silvering the outer part. A concave mirror is made by silvering the outer surface of the piece of a hollow sphere such that the reflection takes place from the hollow surface of the concave part. Now students, just remember that reflection always occurs from polished surface, while the silvered surface is backward, and silvering is done to make the glass opaque. So students, in concave mirror, the bulging part or the outer surface is silvered, while reflection is occurring from the hollow surface. See in figure 1, the hollow surface is looking like a cave, so thus it is named as concave mirror. Students, coming to the convex mirror, it is opposite to concave mirror. A convex mirror is a mirror which is made by silvering the inner surface of the piece of a hollow sphere. So the inner surface is silvered and reflection is occurring from the bulged surface or outer surface. You can see the diagrams of convex mirror in figure number 2, while the diagram of concave mirror is given in figure number 1. The dashed lines means the silvered surface, which is also labeled in both the diagrams. So students, now let us study some terms related to a spherical mirror. Student, first term is center of curvature. So see figure number 3. In figure number 3, there is a complete circle. Instead, this is a complete sphere. And in this sphere, it must be having a certain center. So this sphere was a glass, out of this sphere, only the bold part is taken, while all the dotted part is not taken as a mirror. So in this whole glass piece, we have taken only some part of the glass which is acting as a mirror. So students, what is center of curvature? The center of curvature of a mirror is the center of the sphere of which the mirror is a part. So the mirror is a part of the sphere. So students, the center of curvature is the center of the sphere of which the mirror is a part. Now note that the normal at any point on the surface of the mirror passes through center of curvature. If you take any ray passing through the mirror and passing through center of curvature, that line will be always normal. Normal means 90° to the surface of the mirror. So it means that any ray passing through center of curvature and then striking the mirror, any ray passing through the center of curvature and then striking the polished surface of the spherical mirror will act as a case of normal incidence. Students, case of normal incidence was done earlier in first exercise of the same chapter, and we have discussed there that when the light is normal incident, after striking the mirror, it will get reflected back along the same path. So students, whenever the light is incident from the center of curvature to the polished part of the spherical mirror, the light will get reflected back in the same path, and it is a case of normal incidence. So students, now let us study radius of curvature. Radius of curvature can be defined as radius of sphere of which the spherical mirror is a part of. Students, if P and C distance is to be taken, the distance PC is basically the radius of this spherical mirror. So radius of curvature is the distance between P and C denoted in figure number 3, and it is denoted by capital R. Coming to the third term, that is pole. Pole is denoted by capital P in figure number 3. So students, as you can see in figure 3, P pole is center of the mirror. It is not center of the glass sphere. Center of the sphere is center of curvature. But if we talk about the center of the spherical mirror, that is pole. So the geometric center of the spherical surface of the mirror is called the pole of the mirror. It is the central point of the surface of mirror and is represented by letter capital P. Coming to the next term is aperture. The plane surface area of the mirror through which light rays enter and fall on the mirror is called its aperture. So students, in figure number 3, the silvered part, this whole surface which is silvered, is known as aperture. If we write down the ends of the mirror as AB, then this whole curved part AB is known as aperture of the spherical mirror. Students, in figure number 3, I have shown you a concave mirror. Similarly, if you silvered the inner surface and polished the outer surface, it becomes a convex mirror. So students, all the terms studied till now is represented in both the cases of mirror, that is convex and concave mirror. Now coming to the last important term for today, that is principal axis. Students, it is the straight line joining the pole of the mirror and center of curvature. Students, since it is a line, it can be extended in both the directions. That is, in front of the pole and also at the back of the pole. So the line which is passing through or which is connecting points C and P is known as principal axis. So students, all these terms are very important when we will be doing the ray diagrams. Now coming to the very important part, that is focus of a concave mirror. Now students, what is a focus of a concave mirror? It is a point on the principal axis through which the light rays incident parallel to the principal axis passes after the reflection from the mirror. Now students, kindly observe figure number 4. Students, just remember that focus is always situated on the same side of the center of curvature, and while drawing diagram, kindly pay attention that focus, the distance between pole and focus, is exactly half of radius of curvature. So if we take center of the curvature at a distance of 4 centimeter from the pole, then focus will be situated at a distance of 2 centimeter from the pole. So students, see figure number 4. In figure number 4, the incident rays, the rays which are going towards the concave mirror, are known as incident rays. See the arrows, they are going towards the spherical concave mirror. So all these incident rays are parallel to the principal axis. So when these principal rays, incident rays, strike the mirror, they will get reflected. So when they are getting reflected, all the rays are reflected, and after reflection, they are passing through the focus of the mirror. So see all the reflected rays and their arrows. The arrows are shown towards the focus point. All the arrows in figure number 4 which are going towards focus represents reflected rays. Students, note that the rays of light shown parallel to the principal axis are incident rays, and after reflection, all the reflected rays, what are they doing? They are actually meeting at a point. They are actually meeting. So the reflected rays actually meets at focus in case of concave mirror. These reflected rays are converging at one point. Students, the word converging means all the rays are coming closer to a certain point. Thus, remember this, concave mirror is also known as converging mirror. So, a concave mirror is a converging mirror. Why? Because all the reflected rays are converging, or they are coming closer to a particular point known as focus of the concave mirror. Students, the distance between pole and focus is known as focal length. It is known as focal length of that mirror. So students, now coming to focus of a convex mirror. The focus of a convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to come after reflection from the mirror. So students, first of all, you all kindly observe figure number 5 drawn on page number 4 of your notes sent to you on 30th November 2020. So students, in this figure, you will see that, note that in figure number 5, we are having a ray diagram of convex mirror. Students, in this convex mirror, see, we are having a mirror convex in which the outer surface is silvered. Outer surface is polished, while the inner part of convex mirror, it is silvered. Now students, first we have drawn a parallel incident ray which is parallel to the principal axis. So if we draw parallel incident ray to the principal axis, then at a certain point, it seems that this ray is coming from one point. Actually, the ray is reflected outward. All the rays are reflected in an outward direction and they are not coming closer. See in figure number 5, the reflected rays outside the mirror, they are going away from each other. They are spreading away from each other. While if we just produce them behind the plane mirror, and whenever we are producing it behind the mirror, as we have done in plane mirror also, we have to show the rays dotted. So what we are doing, we have produced back the reflected rays such that all these reflected rays, when produced backward, appears to meet at a particular point, and that particular point is known as focus of the convex mirror. So students, you have to note that the incident rays falls on the polished surface of the mirror, And after striking the convex mirror, the reflected rays moves away from each other. They are not getting closer to each other. They are getting away from each other. And it appears that they are coming from one point known as focus. So students, as the reflected rays outside the convex mirror are spreading away from each other, hence convex mirror is also known as diverging mirror. So students, focus of a concave mirror as shown in figure 4, it is a real focus. Why real? Because all the reflected rays are actually meeting at point F. It is actually meeting or intersecting each other at point F. So, the focus of concave mirror is known as real focus, as the reflected rays actually meet at this point, while in case of a convex mirror, it is known as virtual focus. So students, virtual focus. Why it is said as virtual focus? Because the rays are not meeting actually at this point. The rays are spreading away, but it seems that the rays are coming from point F. So thus, the focus of a convex mirror is known as virtual focus because the reflected rays do not actually meet, rather it appears to meet the focus when the reflected rays are produced behind the convex mirror. So students, with this, I come to an end of today's interactive session. You all are required to read the given notes and practice the ray diagrams. Students, also do numerical number 1 and 2 given on page number 172 of your physics textbook. Do it in your notebook, and while doing numerical, remember that focal length is always equal to half of radius of curvature. That is, focus is equal to r divided by 2. Thank you, students.